Hello, and welcome to Solids and Liquids Investigation 4, Part 4, Changing Properties. After watching this video, you'll be directed to read a few different text passages within your FOSS textbook. Find your FOSS textbook online through Dodea Clever. In today's lesson, you are going to be answering the essential questions: are these materials solids or liquids? And then what evidence do you have for your answers? Our focus question is, how do properties of materials change when they are heated or cooled? And then how can we find out? If you would like to do this experiment at home, here are the materials that you will need on your screen. Please take a moment and pause so that you can collect these materials. Otherwise, I've gone ahead and already done the experiment and have taken a series of photos to help guide you. The three materials that we are going to be using and experimenting with are margarine, ice, and chocolate. You can see in the top pictures a bird's eye view. Then in the bottom, you have a side view of what the items look like within their plastic cups. Please take a moment and observe what you see. What are the shapes of each of those objects? What do they look like? How big are they? Please keep all of that in mind throughout the next few slides. First, I took the ice cubes. What I did, instead of putting them in a hot water bath, I melted them for 5 seconds in a microwave. So what you see on your screen right now is both the bird's eye view as well as the side view after 5 seconds. Do you notice any changes within the ice cubes? Then I placed the cup back inside the microwave for an additional 5 seconds. So then the total is 10 seconds. And after 10 seconds, this is what the ice cubes look like. Do you notice any change now? Keeping in mind we're heating, then I put it back inside the microwave for an additional 5 seconds. So at 15 seconds, has our solid changed into a liquid? Then I took the next object, which was margarine, and I put the margarine inside the microwave for 5 seconds, and this is what it looked like. Now, if you're not doing this at home, I will go ahead and note and tell you that the texture of the margarine it started glistening and it was a little bit softer, but then there was not much change to its shape after 5 seconds in the microwave. So now let's think. What do you think it would look like at 10 seconds? Were your predictions correct? Again, there wasn't much change. You can see around the edges of the cup that the margarine was starting to spread because it was warming up, and then the solid was starting to become a liquid. It's in a transition phase right now. I put the cup back in the microwave for an additional 5 seconds for a total of 15 seconds. Do you think it was completely liquid by then? Let's take a look. Here it is at 15 seconds, both the bird's eye view and the side view. Were you right? Next, I took the chocolate. And again, the goal is to try to see how this solid changes once it's heated. This is the chocolate as it appears after 5 seconds in the microwave. Did you notice any changes? I put the cup back in the microwave, and at 10 seconds, this is what the chocolate looked like. Again, take note in the bird's eye view as well as the side view. As the scientist conducting the experiment, I will go ahead and tell you that if you're not doing this at home, I didn't notice much change after 10 seconds. The chocolate still appeared very hard, and the shape did not change. Put the cup back in the microwave for an additional 5 seconds. So at 15 seconds, this is what the chocolate looked like. Now think to the ice cubes in the margarine at 15 seconds. Both of those had changed its state already. But here the chocolate, it's still in its solid form. So I didn't want to stop the experiment there because now I was curious. I was curious just how many seconds it would take to turn this solid into a liquid. So after 35 seconds, as you can see from this photo in the upper right-hand corner of your screen, the chocolate started becoming malleable or soft. It was changing its form. In the lower left-hand side of the screen, you can see how the chocolate pieces were starting to blend together because they were melting. But I was still curious. I knew that if I put it in the microwave longer, that I might be able to liquefy our chocolate. What do you think liquefy means? So I placed the cup back inside the microwave, and at 50 seconds, these are the results. What did you notice? Again, compare this solid, or now a liquid, or a mixture of the two, with the margarine and the ice. This took a considerable amount of time to begin to melt. Change of properties. Did the properties of the solids change? If so, how did they change? What caused the properties to change? And finally, what change does heat cause? I want you to answer those essential questions in your interactive science notebook or on a lined piece of paper if you did not bring your notebook home. After you do so, this would be a great place to pause for the day. Remember that you have all week in our e-learning environment to complete this lesson and then to finish off the week with an assessment. So answer the questions and then pause the video. You can either continue today or you can stop for the day, but then pick at this point. Welcome back. So as we were learning in the previous part of the experiment, we learned all about melting. Melting is when a material changes from solid to liquid. When a solid changes to liquid, it melts. And to melt a solid, we add heat. And in this case, we used a microwave to heat up our solids, but at home, if you ended up using the hot water bath, then that's how you added your heat. Heating these solids caused them to melt. When the materials melted, it changed from solid to liquid. What can we do to change liquid back to solid? The next part of the investigation is liquid in the cold. How can we change these liquids into solids? Again, with those same 3 now liquids, or in the case of the chocolate, a mixture of solid and liquid, I put those cups into a freezer. And after 1 hour later, this is what the water looked like. Did the water start to turn back into a solid? After an hour, this is what the margarine looked like. As you can see from the photos, it began to solidify. And here's the chocolate. Although difficult to tell in the picture, you can kind of see that the texture has started to change. It started to harden. But a question to ask yourself is, even as this is beginning to solidify or harden up, is it going back to its original shape? In your interactive science notebook, I now want you to answer these questions about liquid to solid. What caused the margarine in chocolate to change to solid? Why didn't the water change to solid? Are these changes reversible or irreversible? Those are new vocabulary words. I wonder what they mean. If you have a home dictionary, go ahead and look up those words. Or you can go to dictionary.com to help assist you. Scientists also oftentimes ask themselves questions as they're working through experiments. Here are some of the questions that scientists would ask in this case. What do you observe about the items that were in the freezer? Did the properties of the liquids change? If they did, how did they change? Did any liquids stay the same? What caused the properties to change? And what change does cold cause? Now, you don't have to go through and answer each of those questions, but I do want you to think like a scientist. So as a scientist, I was still curious if after 1 hour the water wasn't completely solid. I stuck it back into the freezer, and 2 hours later, this is what I saw. Even after 2 hours, we did not have ice. We did not have a complete solid. What do you think the margarine and the chocolate look like? Here's the margarine. As you can see from the bottom of this photo, the margarine had completely changed its shape, took on the shape of a container. So it was once liquid, then it froze in that state, which now it would no longer return to its original shape. It now took on the shape of the cup that it was in. And then we had the chocolate. By this time, I was able to pull the chocolate completely out of the cup. No, I didn't eat it. Don't eat your science. But it did solidify, it hardened, but it did not return to its original shape because when we had heated the chocolate, it started to melt. So now when it returned to a solid, it maintained or kept that shape. So when a material changes from liquid to solid, it is called freezing. When a liquid changes to solid, it freezes. And to freeze a liquid, we put it in a cold environment. Take a moment to review some of the vocabulary that's up on your screen. Feel free to pause the video. Going back to our focus question, how do properties of materials change when they are heated or cooled? When a solid changes to a liquid, we say it melts. When a liquid changes to a solid, we say it freezes. To change a solid to a liquid, we make it hot. And to change a liquid to a solid, we make it cold. Now it's time for you to log into Dodea Cover and click on the plus icon. I want you to read those two texts, heating and cooling, and is change reversible? You also have opportunities for online activities. In Google Classroom, as a follow-up, you need to answer the focus question, how do properties of materials change when they are heated or cooled? Thank you for tuning in. Have a great day.